Our next speaker is Kat Gorinsky, presenting Simplified Troubleshooting through API Scripting. Kat is a network engineer at a large company and has come to us today from Austin, Texas. She has been on the stage countless times as the program committee chair, but this is her first time presenting as a speaker. Welcome, Kat.
Michael?
Yep.
Hi, everyone. So today I'm going to talk about simplifying network troubleshooting through API scripting. So we'll cover why to automate our troubleshooting, why to do API instead of screen scraping. I'll give some examples of typical repeatable troubleshooting. I'll also give example outputs of grabbing the data via the API. We'll cover what skills do we need, who has APIs. I'll show a few examples of some actual code, and then there'll be some time for Q&A at the end. So why automate? I love Jeremy Schulman, and I love this quote. Your network is a crime scene, and you are the detective. You need better ways to investigate what happened and prove guilt or innocence. Most failures have repeatable troubleshooting steps to find the root cause. So if it's repeatable, that means therefore we can automate it in code to get these expected outputs from our scripts. And why waste time typing the same set of commands every single time when you're going to have a similar failure? If you always know you need to do a certain set of commands to find what's wrong, why not just script it? So why API versus SSH or screen scraping, right? Well, API calls are significantly faster. A former colleague and I, we both decided to try our hand at writing a script to install an extension for a security hotfix that we had to install on our switches. The colleague wrote theirs with NetMiko and SSH calls, and mine was PyAPI. We ran them at the same time, and mine consistently ran several, like 3 to 4 times faster than my colleagues did. So we used mine to update the fleet. And most APIs are going to return all the data to you in JSON, which makes parsing it a lot easier compared to screen scraping, where you have to actually format against all that output on the screen versus an actual library. So some typical troubleshooting examples, right? We're going to talk about like link down, error on the link, switch rebooting unexpectedly, a power supply failure alert. You often need to dump your show text and other common things like your show var log, show Qt logs, etc. Lots of things that we're going to have to get that we can get from APIs. So like link down, link errors, right? I need to determine both sides of the bad link if they're not already known. A lot of times my ticketing system might just tell me one side. I needed to go figure out what the other side it connected to was. I need to take a look at the light levels for both of these sides to see if there's an obvious failure in the transmit or the receive. I need to validate the rate of bouncing if it's applicable and if this is seen by both sides, because sometimes I might just have one side going nuts and the other side still thinks it's link up when it shouldn't be, right? I also want to grab the data on the optics and the serial numbers in case I need to do a replacement of one of those parts. I might also need to get relevant show version and inventory very quickly as well, which I can do in API. So if I'm going to have to swap a part or open a TAC, I can have my scripts, quickly grab my host name, my model, my OS version, my serial number. If it's a port, right, I can get the optic and the model and that serial number as well. So this will make it a lot quicker now when I go to open a TAC case later. So I'm going to check for common outputs. So for me, when there's a bad link, I look at these 3 common outputs, right? So I've got my show interface counter errors, my show interface transceivers output, my show interface Ethernet MAC detail outputs. And so in this example for Arista's PyAPI, the first 2 came back as JSON. So I threw them into some tables. And then the last one just returned text. It wasn't JSON formatted, so I just printed it nicely the way you'd expect to see it on the switch to the screen. So lather, rinse, repeat, right? In the case of bad links, I want to validate the other side. So then I'll also use like LLDP or descriptions, or if I have an inventory database to see if it's down, to figure out what my other side is so I can then run the same set of commands there. So again, now I've got commands going to run on side A, commands going to run on side B. I don't have to redo anything, right? I just can reuse that same code to run it on both sides. You might get an unexpected switch reboot and try to figure out what's going on there. So there's 2 things on an unexpected switch reboot that I personally always check. I'm going to look at the uptime of the code version of the switch. I'm going to look at what the switch thinks the reload reason was. Show reload cause on the example of an Arista. And it doesn't take long to log in and do these things, but still it's just so much faster if I just type a switch name and run the script against it and just get it right on the screen right there without having to do any logging in. So here's like an example of reload diagnostic output from my script. All right, simple, it's to the point. In the case I need to open a TAC, I can just copy and paste all this into that TAC case. And in the case of this one too, I've also got the ability where if any debug information was returned, I can write it right to a file on my local machine, so it's ready to upload and send to TAC as well. So I don't have to go and copy and paste it out of the switch. Another thing I've seen a lot of is FPGA errors on switches, where you'll require a reboot to clear the FPGA error. And when I get a ticket in, I might want to make sure it's even still present. And then after I do a reboot, I want to make sure it's still there or not. So I've got another script, for example, that tells me where the FPGA error is. If this is a one RU switch, but like on a chassis, you might have multiple line cards that could have FPGA errors. And you can figure out exactly which card has your error and see when it happened. Is it still happening? Is it incrementing? Power supply failure is also very common if you do large-scale data center build-outs, right? So again, I can get show inventory. I can grab just the power supply section, see all of my PSUs and their serial numbers. I did obviously scrub a lot of this data if you guys didn't notice, so hence why they all have the same serial number. That's obviously not real data. I can get the show version in case I need to do a TAC case, in case I have a bad PSU or something. And I can also do the show environment power details too to see like what went down, how long it's been down, did it come back up, what's the power level and everything. I also find that TAC consistently asks me for the same set of files. I'm sure you guys see the same thing too from your different vendors, where they're always asking you for like these same 4, 5, 6, whatever outputs, right? So you could also use your API scriptings to dump all of those into files for you. So again, you don't have to go log in, you don't have to start logging to the screen. You can just have the script run it and save it all to individual files for you, so that again, quick, easy attachment for your TAC case. In the case of some of these, they might return plain text, meaning to strip your new lines, but again, pretty easy to do with Python scripting. On Arista at least, you can just type any command and pipe JSON, and you'll be able to see if it's going to return to you in plain text or regular API JSON results. So you know when you're writing your script for each of those commands, whether you should be expecting plain text or JSON when you actually write the code. So what skills do you need to do this? So for my examples, a working knowledge of Python and some time with your vendor's API module to understand anything special about their commands. Most vendors do have APIs, and some have Python modules that will make your interactions even easier. My examples are all Arista, because that's mostly what I work with, but other platforms do have these options as well. I have a bunch of links at the end of the presentation too to help you guys get started with other vendors as well. Right, so Arista's got PyAPI, Juniper has the PyJunos EasyNC. I couldn't find an official one for Cisco Offbox, but there's lots of user-created ones. And then Nokia does like gRPC and protobufs. So JSON also is really useful to have knowledge and understanding of how JSON works, JavaScript object notation formatting. Most of your APIs are going to return data to you in JSON. So if you understand how it's stored with name value pairs separated by commas, in the case of JSON, curly braces will hold your objects, and then square brackets will hold your arrays. Once you understand how that works, it's super easy to manipulate your outputs and just get the relevant parts within the JSON that you need for your scripts. So here's some example code that I've written. So one thing I will emphasize that I didn't do when I first started writing these scripts was being able to reuse the same bits of code over and over. If you're going to be doing that, I highly recommend you write a shared library file and make a class. Years ago, I did not do that, so I was reusing the same chunk of code at the beginning of every script I had over and over and over. And that was something I did a couple years ago. I started rewriting everything and making classes for those same kind of calls and node definitions that I was going to do. So in this example, I'm just showing like how I create the node, which is my switch device with PyAPI. Timeout is an optional in the case of the Aristas, but I found for some things like show tech, if you don't increase the timeout, it might not actually finish. So also something useful to keep in mind for any of your commands on API that may take longer than your standard timeouts, that you may need to increase that on those. Next, all right. Here's another example of a show inventory, for example. So in this command, I'm dumping the show inventory output from the switch. And then I'm actually making it so I can then narrow it down further when I call this specific definition, where I can just tell it that I just want the inventory for interfaces, or just power, or just storage, to make it a nicer and more shorter database to work with when I'm calling it later. So, and again, JSON formatting, so very easy to narrow that down. And yeah, so just another way to make my life easier when I deal with the subsections. Here's a show version example. So basically, show version also comes back in JSON. There are some differences in how you're going to interact with things based on your version. So in this case, I added something called switch CLI commands old versus new, because they changed how you interacted with the CLI. So when I was writing other scripts, when I ran the show version, I needed to know, was I on an older version of EOS or a newer version, because it was going to change the commands I was going to push on my API scripts for other things. So I built that in there too, based on what I saw for the EOS version in this example. And then I reformatted the way the data was coming back into just the ones I cared about and the formatting I cared about. Next. Current uptime, this was kind of a fun one I wrote. So, when you have values like the time of a last reload, it's easy to take normal Python and then manipulate that and to actually get it into a more human-readable format. So on your switch, when you do like, a show uptime command, you're going to have a human-readable format because it's already doing that for you. But when some of these scripts, you're just going to get like a really big number. And so you can use things like datetime and then UTC from timestamps to actually convert it back into a human-readable format when you're pulling it from API. Because again, it's very confusing if you don't know the UTC timestamp for that. So if you can make it back into a normal value of days, months, years, a lot easier for TAC, your fellow coworkers, et cetera, to take a look at that data when they're running the script. Next. So you don't have to limit this to just troubleshooting. So you can also use this for tedious tasks. One of my personal favorite and one of my original scripts I wrote when I started learning how to code against the PyAPI module for Aristas was I wrote one that actually updates port descriptions based on LLDP, ARP, IPv6 neighbor data, because it just removed the human error after we were done doing build outs, especially if we had connected a whole bunch of servers. The LLDP was much more accurate than me just trying to guess or have to look at a spreadsheet and then type it all in for what the interface descriptions were. And in the case of a script like this, you run it and like in seconds, all of your port descriptions are accurate for where they actually go and what they're actually connected to. Compared to if I was trying to manually go type in everything based on the build patch plan, it would take me a lot longer. And I used to do that. And it was very tedious, and I hated myself for it. So, hello? There we go. Cut out for a second. You can also use this to do things like pre-upgrade flight checks. Before I upgrade a switch, I want to check on my show IP ARP, my routing tables, and all that stuff, right? So I can get all of that stuff I'm going to do before and after for an upgrade. Do my upgrade, and then I can just diff the two files, which makes that a lot easier now, because I'm going to do it anyway before, but I was going to do it with a start logging the screen and then save it to a file, and then start logging the screen and save it to a file again. Now I just run the one script. It just shoves it all in a single file for me. No logging of screen required, no logging to the switch required. It's just grabbing it all from the API. And so I can quickly vet after the upgrade to make sure that nothing actually broke, didn't come back up, I didn't lose a bunch of routes or anything else like that. You can also check like LSP on your MLAGs. There's just lots of show commands that you might want to look at before and after, especially when you're doing an upgrade where you might have that potential on a reboot where something doesn't quite come back the way it should. We also use it for remediation as well because it makes it a lot faster, right? So like installing extensions, like hotfixes. You can also do it to validate if you even have the extension on there or not, so you don't waste time like pushing an extension that's already been installed. Or if you even need to do it for this specific version, because sometimes the hotfixes are only applicable to certain versions of EOS or certain versions of hardware modules. So again, to save you time, you could shove all your switches into the script, but if you've got all these if statements written in there, it's only going to go and install your hotfixes on the ones that actually need it and don't already have it. So just, again, removing lots of room for human error and speeding up the whole process. And then like things like pushing baselines and ACL config remediations as well, very easy and quick to do via scripts. So really the possibilities are only limited by your creativity. So if there's no API, I mean, there is always SNMP, because not all devices do have APIs. So I'd say SNMP is probably your next best option, for at least for some things like errors and discards and link states. And that's what lots of your monitoring tools are going to be using already. But of course, for links and stuff, you're going to have to map out those OIDs for your if descriptions to your errors and discards and bits. So it's tedious, but it is another option you have if you don't have an API on your device. And then, again, once logic has been written, though, right, SNMP is still, again, another faster way to get the data compared to SSH screen scraping. So backups. So optimization tips I have. Try to run your tool scripts locally to the site for the best return times on API, SNMP, and other calls. If you have more than one site, I have things globally, right? So I don't necessarily want to run something from Atlanta that is like checking something in Israel, right? So if I've got a local box there, I want to always try and run those scripts there because it's going to be a lot faster to dump it on a local server and not have to deal with latency. Cache data when possible to speed up your scripts runs even more, like things like interface data, names and stuff, right? So a lot of companies have network source of truth databases where things like your interfaces and your peers, et cetera, may be stored. And if you can use those Instead of having to log into the switch first, that'll also speed up the runtime of your scripts if you're not having to pull for data that is already stored somewhere else. So, and then create outputs formatted in the way that best is suited for your ticketing tools and systems. So like in the ticketing system that I use at my job, I add this little code pre/code block, and then ta-da, and if I paste that into the comment section of my ticketing system, it's now formatted in a nice code block. So I just put that in the script. So I don't have to remember to go and do that and then paste my script inside every time, right? So you can include things like that for your ticketing systems as applicable. Security best practices. Don't save your API and SSH passwords or your SNMP community scripts hard-coded in your scripts, please, because that's just really bad. So I like to use getpass, or you can also store in secure environment variables. A trick I use too for environment variables is I can do if you do a no space history, you can do a space before your environment variable for your password when you first log in. And now it's not going to be stored in the scroll back, but now for that login session, my password is stored temporarily, but in a secure manner that no one else is going to see while I'm running my scripts. But I don't keep it stored in my actual regular environment variables that someone else could log in and look and see, right? I also recommend trying not to write current employer-specific code because then you can't share that code, right? And it's going to not work for other people, right? So I like to make things that work for everybody. So I try to get away from doing anything that's going to be very unique and specific to my employer. And always plan ahead for multi-vendor environments. Like most of my scripts right now are doing Python PyAPI, but we also are always considering like how could we do these against other platforms, because I might not be using Arista for the rest of my life, right? We might switch one day. And you want to be able to just easily be able to transition your codes if that happens. So keep that in mind. So what troubleshooting do you all frequently repeat? I am very curious to hear about everyone else's use cases. I'm a big believer in talking and brainstorming on best practices, if you didn't get that impression from either slide. And I really don't think it's good to isolate ourselves, especially like now in a post-COVID world. We've learned collaboration is very important. You can reach me at kat@gorinsky.net, and I also sit on the Network to Code Slack pretty regularly. And if you stay tuned, most likely later this week, I will have my example troubleshooting scripts posted to my GitHub, which is linked there. So stay tuned for those. They will be coming soon. Come on, there we go. And I've got time for question and answers if anyone has any. You wanna go, Chris?
Yes. Hi, Chris Woodfield with DriveNets. You mentioned that Python is your language of choice here. Do you find yourself spending more time in an interactive shell when you're doing development work, or are you more comfortable using, say, a code editor and pushing your scripts out to run from files when you're building and developing automation?
I personally do a lot where I just sit in a code editor, save it, and then push it over, because I'm writing usually on my machine where I can't actually run the scripts because I want to be in the code editor, and then I've got to push it to a jump host, which is actually allowed to talk to my switches. So I do a lot of that where I write it on my try to get it as accurate as I think it might work from my device, push it from the code editor, do a little git push pull, and then hop onto my jump box, see if it actually works, figure out what didn't break. If it's a simple change, I'll edit it on the jump host, and if it's something that needs a little more nicer formatting, I'm going to go back to my machine and rinse, lather, repeat.
Okay.
So yeah.
Great, thank you.
Mm-hmm.
We do have one question that's from the online community. You talked about updating port descriptions based on LLDP, ARP, and IPv6 neighbor talk. Can you provide an example?
Yeah, so the script I have for that one, for example, that is going to look for, I try to do LDP first. So I've got, it's a lot of if statements on that one. And so I look for LDP first. If LDP is there, then I'm going to use that as king because that's the other device telling me for sure that's what's there. And then I'll take a look at ARP next, right? If it's got a v4 ARP instead, then I'll use that. And if it doesn't have that, I'm going to go look for the IPv6 neighbor table because there's no IPv6 ARP, as you guys might know. So I'll check in the IPv6 neighbor table as well. But yeah, so I kind of go through it in that hit list order. And then I also have some additional fun logic if there's like port channels so that the port channel gets one name on ARP and the physical interface can get LDP if it exists. And if there's no LDP, because maybe I have a really old device that doesn't do that, I will also copy my port channel description that I have over to my physical interface that's missing LDP. So,
thank you, Kat. That was from Justin. We have another question online that's from Michael Brooks. Programmers, developers, scripters have a bad habit of saying, quote, just, ... For those of us who have no idea what that means, where do you suggest we start?
So just for starting, I'm trying to figure out where I said that.
Saying just right there.
I mean, I guess start like by learning some basic Python would be where I'd say start, and then take examples just, of things that you need to do that you don't want to do by hand, right? And then start by looking there into APIs and see if there's calls for those things and how would you write that call, I guess. But Python's definitely the thing I'd start with because most of these modules are all in Python. Can I go forward actually here? Right, so I've got a bunch of useful links at the end here, like for Junos, for EOS, for Nexus, I believe there's one more, and then also some Cisco Python ones and some module documentations.
Yeah.
So if you would like some help getting started, I'd probably look at these documentations here that I linked. So yeah, there's the 2 pages there of examples and places you can start. So.
Meaning just go here, just grab the library.
Gotcha. Okay, thank you, Michael, for that clarification. I guess what I mean is like the show command you're doing, right? That would be the just go to that command, and then that would be your essential library. It's your JSON output that you're getting back. Hope that answers that question. But also use these links too for if you're trying to figure out where to start on the programming side.
Just like Jordan had mentioned earlier, learning Python.
Yeah, Python.
Python.
Yeah, and we'll be having a network automation tools panel tomorrow too to compare and contrast various different tools. And we'll also be talking about Python and Go, because Jordan had also mentioned Go, which I don't know any Go. So, yeah.
Any other questions from the community online or in person? Wow. So I want to guess we're almost 20 minutes ahead of schedule.
Yep.
Get a round of applause for Kat here.
Thank you.
Thank you again, Kat.
Thank you.